thank you. Apologize for my horrible play on words, but I'm getting familiar with the quantum community, so wanted to do my part to participate with the chemistry lingo. What I want to tell you about today is a little bit high level, admittedly. I am here for the event this whole week, so if you want to dig deeper and you want to chat, let's do that. But I want to give you a bit of a high level overview of what BASF is doing to try and participate and be a part of this quantum ecosystem. So let's see if this works. Oh, too fast. Great. So before I do, just a real quick BASF Venture Capital at a glance, a little bit of shameless plug here. So the fund stood up in 2001. We're $250 million, an evergreen fund, typically doing $1 to $5 million check sizes. Series A is the sweet spot. Global investment mandate with fund managers all over the world. Typically taking a minority share, co-investing. We can lead, just depends on the stage. Maybe what I would say, apologies, second play on words here, investing to catalyze change in the chemical industry. That's right, catalyze change in the chemical industry. So we really want to make investments that move the chemical industry in a new business direction. Kind of at the risk of sounding arrogant, because we're a pretty big and broad company, if we make those changes, chances are good that it will be there'll be a lot of upside potential for BASF. Great. So let me lead off with a quote then, getting back into the talk from our CTO, and just to give people a sense of how important quantum computing has become across the BASF organization and all the way up to the board level. I'm not going to read this to you, but Melanie here is talking about how quantum computing is going to be arguably very disruptive or very critical to the chemical industry, like everybody in this room would know. It's going to be critical to many industries, but not the least of which is ours. Likely because, or I would argue because, some of the first quantum use cases are going to really be around simulating and modeling chemical environments. So, just really nice to have support at that level from our leadership. So what is our vision for quantum computing? Like I mentioned, we sit in the position that it's really going to accelerate innovation for us, okay? So we've all been doing it for a long time. We've been using classical computing methodologies in an attempt to accelerate innovation. And quantum computing, if and when, we really believe when it gets there, is really going to step on the gas pedal a little bit. Chemical simulations, of course, I'm not going to quote Feynman to anybody here. Maybe I will paraphrase Feynman if you want, in that the world is not classical. Nature is not classical, it's quantum. And having the tools in hand to simulate those quantum environments is going to be very powerful. As an aside, I'm new to the quantum space, so if you want to see someone, like if you want to see imposter syndrome, you should just see inside my brain right now, being in front of all of you here today. But so the first and foremost, and I'll give an example of what we're thinking about chemical simulation. We know that this is going to be important and impactful for BASF, specifically in the quantum space. Optimization, machine learning, and this is more optimizing our supply chains, processes, plant operations, all this other stuff that goes into running a chemical company. And machine learning and AI, specifically around like formulation optimization, things like that, where you imagine the parameter space that you would have in a, BASF may provide 1 or 2 active ingredients to a company that's putting 20 into a formulation. It becomes very quickly very complex. And finding ways to kind of parse through that and land on the best design space will be very important. We're in the position right now where we believe that there could be advantage or use cases for quantum at BASF, but that's a little bit more in like the if mindset right now. And again, coming back to the chemical simulations, it is for sure, and we need to find those use cases. So how can quantum computing help develop chemical catalysts? This is the example I want to give to some extent. So BASF uses catalysis in 80% of our production. We also sell catalysts through our catalyst division to hundreds of companies globally. So you can find our catalysts everywhere. For the non-chemists in the room, a catalyst is something that essentially accelerates or speeds a chemical reaction without itself taking part in that chemical reaction. So it does this by lowering typically the transition state energy of a key step, and then therefore allows you to go at lower temperatures, lower pressures, or faster at the same temperatures and pressures. What we're doing is nothing terribly exotic, but the use case here is, to the extent that I can describe it, is trying to accelerate catalyst development by taking a first guess with the classical computer. And maybe people in this room know this, but BASF actually owns its own supercomputer named Curiosity. At one point, it was on the top 500 list. That was long ago that it was on the top, but still important to highlight to people that high-performance computing in general is very important to BASF. So making a good first guess on Curiosity, we can then pass the result of that first guess onto a quantum computer, which will, of course, in principle, refine that very quickly, pass it back to the classical computer, and we can do iteration upon iteration of that to zero in on an ideal catalyst candidate before actually then going through the effort of synthesizing this in lab, bringing it to a pilot plant, et cetera, which is very time and costly. It's very time intensive and costly. Another example, though, I want to point out is our ambitious climate targets. So BASF wants to do 25% Scope 1, Scope 2 reduction of greenhouse gas emissions by 2030. That's compared to our 2018 numbers. But by 2050, just like many other companies, we want to be net zero. And if you think about where can quantum start to have an impact, this is coming back to kind of some of those if statements like the supply chain. We have very complex supply chains, both on the sourcing, but then also on getting those materials to our customers. One way in which we can start to have a greenhouse gas emissions impact is thinking about circularizing or closing the loops of supply chains. This is very complicated to do, and we have many bruises from attempting to do this, particularly in the plastic space and some in others. We're venturing into the battery recycling space as another example. But closing those loops could be one way of really mitigating our greenhouse gas emissions. Now, I mentioned catalysis as an R&D example in more quickly getting to discovery, but also developing catalysts that that allow reactors to run at lower temperatures and pressures and still achieve the same yields is, of course, advantageous from a CO2 emissions point of view. And there's also even things like predicting toxicological behavior, but doing that in silico, as opposed to what we normally do now, which is test on animals. There's ethical dilemmas with that we're trying to work through. But of course, the other issue is that's incredibly time and it's often cost prohibitive and generates a lot of CO2 emissions as well. And then lastly, and not least, BASF operates 6 world-scale facilities, soon to be 7, that were under this concept called Verbund. If people haven't heard of this concept before, it's really about connecting all the different operations in a plant to minimize your waste. The idea would be that naphtha, for example, is a feedstock that comes in the front end. As that moves through and up the value chain and increasing in chemical complexity from one plant to the next, what we're really trying to do is take waste heat, waste chemistry from one plant and feed it over to another in an effort to really minimize, basically we don't want any waste at these facilities. You can imagine if you start thinking about all the variables there, it becomes incredibly complex to optimize. And this is where quantum computing could actually help us out a little bit too. So what are we actually doing? One thing we want to do is actually prepare for the quantum leap, right? We want to be an early adopter. Are we building a quantum computer? No. Maybe someday we'll be an owner of a quantum computer, which would be very exciting for our own captive use. But right now what we're doing is we're preparing for this quantum leap. And I apologize, that's my third and last wordplay, so you won't get any more of that from me today. Use cases right now within our research organization include identifying, validating algorithms. So we're even trying to develop some of our own algorithms. And that kind of moves into the second part where we're collaborating with many startups. We're collaborating with many academic folks in academia and then also lots of industry partnerships. And I'll highlight some of those on the next slide to the extent that I can. And then finally, we're working in political and like industry groups to essentially keep a long view on quantum, to keep it relevant in the eyes of legislators, to keep it on the radar of the industry in general, so that we don't lose sight of its value and what it can do for us. Last but not least, and I'm sure many of the people from quantum companies here in the room or at this conference in general could appreciate the challenge with recruiting talent and expertise, and we're trying to do that to the extent that we can. Some of which is training up our own talent that's already in-house, that comes from high-performance computing backgrounds. Some of which is hiring people that have more quantum-specific backgrounds. But however you think about it, we are trying to build up a small and competent team to aid in partnership and to aid in giving us some directionality to what we want to do in the quantum space. Okay, the last thing we can do, I'm here from venture capital, so again, I gotta mention that we can invest. The two examples we have in our venture capital portfolio are Zapata. I believe everyone in this room probably knows Zapata. We invested in 2019 in their Series A. They're located in Boston, essentially doing enterprise quantum. Christopher would probably say it much more eloquently than I would, but an investment we're very excited to have been an early part of, quite early from BASF's perspective, especially back in 2019. And then more recently, I led an investment into a fund, a French-based, a Paris-based fund, but also with a presence in North America called Quantination, that's doing early stage investing. I'm sure many people know Christophe and Olivier and the Quantination team, but we've done this to also try and keep our finger on the pulse more broadly of the quantum ecosystem. So not just hardware and software, but also quantum networking, sensing, and even some of the fundamental physics behind that. Please don't ask me any questions about the fundamental physics, just I take my word for it that we've invested in their expertise. So this slide, the last slide I want to highlight to just give people a flavor. Now this slide is, I would argue, somewhat comprehensive, but it's by no means exhaustive. The reason it's not exhaustive is unfortunately you can't share everything that we're doing, but we're trying to share everything that we're doing here that's publicly known. So lots of academic collaborations. You'll see there's kind of a heavy German focus here. Again, it's not only Germany. There are many other academics we're partnering with. Industry and commercial partnerships with Robert Bosch, with HQS, Google Zapata, Pascal, quite a few familiar names I'm sure people see up there. And then finally coming back to this government and interest groups, a whole mess of alphabet soup and acronyms over there. But again, really trying to keep a long view or take a long view on the development of the quantum ecosystem. How do we influence policymakers, change makers, all sorts of things like that. So with that, I'm going to conclude. This was pretty fast. I apologize if it was a little bit too high level, but I've hopefully left enough time for you to ask me some questions. We want to make quantum computing usable. This is not a sprint. This is another quote from senior leadership. It's definitely a marathon. I think everybody in this room who's been fighting the good fight in this community longer than I've had the pleasure of being a part of it can appreciate that. But we are committed, we recognize that it's a marathon, and we really want to connect. And to that end, I would just close by saying BASF has a bit of a website on quantum computing. If you just Google BASF quantum computing, you should get there. You're welcome to follow us on LinkedIn. You're welcome to connect with me again. I'm here for the rest of the conference this week. And I'm also happy, you can either send an email directly if you'd like, or I can connect you directly to our quantum computing colleagues who kind of fall under the bucket of next generation computing at BASF. So with that, I'm going to thank you for your time, and I'd take any questions you might have. Please.
Can you give an example of like one specific problem or reaction or thing that you would love to see solved by quantum computer that you can't solve, that you can't approach with a big PC today?
That's a good question and a better question for my colleagues who are in the weeds. I'll give you a personal example though. So I'm pretty interested in the battery space. BASF makes cathode active materials. I don't know that you can't solve the discovery of new materials maybe you can solve that classical computing alone, but I'd love to see discovery of new battery materials as an example. If we could do that, I think that would put us in a very advantaged position for the business that we currently have, which is selling cathode active materials. So it would help us differentiate even more. So that hopefully that's a decent example. Yes, please.
Okay, I love your talk.
Thanks.
Just a quick question. Can you guys give us a sense of the R&D life cycles of these new catalysts or materials?
Yeah, sure. I'll give you an example from my own personal experience. I can't speak to catalysts. I was never in that R&D group, but I started in a polymer R&D group at BASF. And just to give you a sense of how challenging it can be, I made emulsion polymers. Emulsion polymers go into latex paint. It's not particularly the most sexy science out there. There's good margin. There's small but large margins to be made. Thank you. Is that 1 or 5? 5. Thank you. But the point there is this is the first commercialized industrial polymerization technology. So we've known how to do this for a long time. And I would say the development cycles, even there, introducing something new and probably, slightly innovative, but important to our customers, was a couple of years. So you can imagine for something groundbreaking, the kind of effort, we're talking at best one, realistically 3 to 5 year kind of development cycles for new materials. Yeah. That's also assuming there are no enormous regulatory hurdles, which I didn't mention. Yeah. Yeah. Yes, in the back, please.
How would you, you said you also engage with academia, right, on research?
Yes.
So how does that work? Would I just contact that email or you?
Actually, if you want to talk about it, talk to me. Actually, my previous job at BASF was doing academic scouting and partnership here, actually, in California. And we have vehicles in place for how you might do that. But it's pretty standard sponsored research agreements that get negotiated and just have to have the right use case and the right interest inside of BASF to sponsor it. Other questions? Those are all good ones. I'm waiting for someone to ask me to derive something so I can tell you no. Cool. Christian, please.
Are you guys looking like equally at long-term like fault-tolerant quantum computing as well as like NISCO, or is there a preference?
I would say we're relatively agnostic. I think we just want to be in the position to use the tools that are available and not fall on our face when they are available. I mean, of course, I think long-term, yeah, the bring us your most powerful, well-equipped quantum computer. We'd love to be a user of it. Yeah. Please.
I didn't really notice ML brought out on your slides anywhere.
Say that again?
I didn't notice machine learning or any of that brought out on your slides anywhere.
Yeah,
What do you think about ML in this space?
it was on one of the slides very briefly. I can go back to it. We feel, where is it? It's on the far right here. I think the best use case for BASF is a B2B company, unless you can probably remember back to the days when we sold cassette tapes, but we don't have anything like that anymore. So almost everything that we sell is finding itself into some version of a formulation. And I think that's what we view as the biggest opportunity for machine learning is optimizing those formulations. Or you can imagine being able to propose optimized formulations as a service to our customers, right? Here's BASF product A. It might be best if you formulate and use it formulate and use it in this way, and that's what we've learned. I would say, that being said, the caveat here is we're not fully convinced that this can't be done purely classically, and that's the feedback I have to relay to this community from our quantum computing team. So we're looking at it, but not yet convinced. Please.
What has been your experience of actually using quantum computers? Like
My own personal experience or the BASF's experience?
BSF, like getting runtime, the computer stopping in the middle of the.
That's a really great question. I don't have an answer for you because I haven't been in the weeds actually in the day-to-day. But I mean, we are partnering with several folks to get what time we can, I think, on their hardware to co-develop algorithms, things like this. So I couldn't say the specific experience, but I'd actually, that's a really good question. I'd happily chase the answer down for you, somewhat selfishly for myself. I have 1 minute. Matt.
You're focused on hybrid computing.
Yeah.
So,
Yeah.
sensible one. So do you have a feeling for how much, if you were spending per year X dollars, how much you were going to be spending on classical computing?
Oh man, I don't even. I'm trying to think of a way to answer that. Maybe let's keep that conversation going. It's a really good thing to think about. I could think of it in terms of team size at BASF and how many people are, let's say, tapping into classical resources versus quantum resources. And the reality is there's far more using classical resources right now. But it'd be hard for me to even put a number to it, to be honest. It's a good question. Yeah, I mean, I could tell you overall on R&D, BASF spends $2 billion a year. Of that, I don't know how much is on compute and then how you parse that out from there. Yeah.